Right. When we left off last time, we had a working servant server, but it was a very boring one because it only had one post endpoint and the endpoint didn't do anything when invoked. So let's spice the server a little. Uh, in particular, let's make it keep some internal state that keeps track of how many times the post endpoint has been invoked. So in Haskell, uh, to keep some state that is shared across threads and across handler invocations, we need to use a mutable reference. And for the purposes of keeping a counter, an IO reference will be enough. So let's make our server constructor actually take an IO ref as oh, an IO ref of int as parameter. And let's allocate the IO ref at the beginning in main with initial value of 0, and let's pass it to our server constructor before converting our server into a warp application. So if you remember, our handler lived in the or handlers lived in the handler monad, which it was a type which is built on top of I/O with some other features, but in particular it has a monad I/O instance, which means we can lift any I/O action to a handler. And what we are going to do is in our handler we are going to lift I/O. Let's import it. We are going to modify the IO ref. We are using the strict version of modify, and we are going to increase it by 1. Okay, now we have internal state on our server. Each time the endpoint is invoked, the ref will be increased. But we don't have yet any way of actually inspecting the value of the counter from outside. What we would like to have is like a separate get endpoint that returns the value of the counter. So in servant, in order to have multiple separate endpoints, I like to use a feature called name roots, which allows you to use a record, a normal Haskell record, to organize your different endpoints. So I'm going to create a record called counter, which will be parameterized by a mode and with a field called counter of type, and I'm going to slot my earlier endpoint definition here. So what is this mode type parameter? Well, mode means whether we are using counter as in server mode to actually define a server, or in client mode to actually generate like client functions for each endpoint. And this new type operator here is a type family that computes at the type level, very much like server. And when mode is known, it takes this endpoint definition and transforms it according to the actual mode. So if the mode is server mode, it will actually create the handler type for this particular route. So uh, let's switch our main API to actually use our record of routes. And this is done with the name routes combinator. So how does it work? How does it work? Remember, server transforms our abstract API to actually generate the type of the server. So when server encounters a name routes something, it takes the record and in mode it slots like the server type, server mode. And this means that this type operator will take the server mode and transform the endpoint definition to a handler endpoint. Okay, we can actually, I forgot. Our record of routes must derive generic. Why? Because we need to allow a servant to actually inspect the structure of the record of routes. Okay. Actually, we can inspect the new type here. So now the server that we must provide is actually a value of type counter. So let's update our server definition. So now it must be a counter with, of course, a field increase counter. And that's it. It seems that it compiles and runs normally. But of course, we need yet to we still need to add the new get endpoint. So let's do it. Let's update our record of endpoints with inspect counter, which as before will have a mode. And before we had a post, now we will have a get. But this get, unlike the post no content, will be parameterized by two types. One type will be the type of the values that we will return from the endpoint, which will be int. And the other parameter that is needed for this server combinator is a type level list. A type level list of what? Of content types into which the value we return may be encoded. So for this example, we are going to use JSON. And it doesn't compile because, of course, because now we have two fields, we need to use data instead of new type. Okay. And now it tells us that in the implementation of our server, we need to provide inspect counter, which needs to be of type handler int. So this will be easy to do. We simply lift the IO, a ref of the IO ref. Oh, no. Okay. And this seems to be enough. Let's try to run it. Perfect. So let's do let's perform a few curls. Return 0. because we haven't invoked the post yet. So mm, let's invoke the post a few times and let's invoke the getEndpoint group. Okay, we see that now it returns the actual counter. So now we can inspect the state from outside. So this is very nice. Some small notes that here we have this path fragment duplicated. We could factor it out and do it, and we can do it like this. We can actually use the path separator type operator and put the counter fragment outside. And of course, we can delete it from here. And basically nothing will change. It will behave as before. And one last note, these names are internal to Haskell. They are just to organize the implementation. These names aren't reflected in the actual paths of the API. The paths in the API are controlled using like these kinds of type level strings. And this is all for now. Bye.